स्टार्ट करते हैं अपनी लास्ट थ्योरम, दैट इज व्हाट, सब्स्टिट्यूशन थ्योरम. Substitution theorem. Okay, so first point about this theorem is what? This theorem is valid for LTI system. Now the first point about this theorem is what? This theorem is valid for LTI system. Now what is the meaning of LTI system? You will listen this word in your signal system. Linear time invariant system. So this theorem is also valid for linear and time invariant system. Next point about this theorem is what? What is this? That in this theorem is also called, this theorem is also called compensation theorem. Compensation theorem, which is used in antenna, Okay, now what is the last point of this theorem is, this theorem, according to this theorem, a particular current source or particular voltage source or current through a branch or the voltage across a branch is represented in a different way. How? We will see. Just by one example, we will see how the substitution theorem is applied. So I will just take one example. I am having 30 volt source and we have 6 ohm resistance, and also we have a load point of A, B, load resistance of 4 ohm. Okay, now first we will calculate the current and voltage. Now this is a series circuit, and in the series circuit we will have Ohm's law, that 30 divided by 6 and 4, that is 10. So I is 3 ampere. Okay, so this current is flowing from, now this is the voltage. The voltage VL across this 3 ohm is, VL is 4 into 3 is 12 volt. So meaning क्या है इस थ्योरम का, देखिएगा यहाँ पर, we have a branch in which 3 ampere current is flowing, whose resistance is 4 ohm, and the voltage across it is 12 volt. Okay, now according to the substitution theorem, a linear time invariant system, the current through a branch or the voltage across a particular element can be substituted as. So we can substitute it in various ways. What are the various ways? Let's see. First way is, like, it is 3 ampere current source. It is a 3 ampere current source whose voltage is 12 volt. This is the first way. Then the second way I can write as, it is the 12 volt source whose current is 3 ampere, the second way. And the next way is what? I can represent like that. It is 3 ampere, sorry, it is 2 ampere. It is coming like 3, and here we are having a 12 ohm resistance whose voltage is 12 volt. So 12 divided by 12, that is 1 ampere. So 3 is coming, 2 is here, and 3 is, so 3 is in, 3 is out. So it is a third way. In the next way, I can represent this branch as, this is 3, and we have, it is 3, no? So it is, sorry, it is 3 ampere coming out, 3 ampere, it is 2 ohm. Then we have like that 6 volt. Okay, so let's check. Now, what is the meaning of this theorem? According to substitution theorem, for a linear time invariant system, the current through a branch and the voltage across a branch can be substituted in many ways. As suppose I am having a AB branch whose current is 3 ampere and voltage is 12 volt. Now the first way to represent this branch is the volt by the current source whose current is 3 ampere but the voltage is 12 volt. Yeah, it is true or not? Yes, it is true. Now the second way to substitute this AB branch as 12 volt voltage source and current through it 3 ampere. It is 3 ampere, not 8 ampere. It is 3 ampere. Now the third way to represent the branch AB whose current is 3 ampere and the voltage is 12 volt. So I am having 3 ampere in. On the right hand side we will use 2 ampere, and on the left hand side, my left hand side, I am taking 12 ohm resistance and whose voltage is 12 volt. So in parallel the voltage remains same but current is what? 3 ampere. Okay. Next way is to represent this branch is 3 ampere current and 2 ohm resistance in series with 6 volt. How it is possible? But current is okay, it is 3 ampere but the total voltage is 12 volt. See how the 12 voltage is. Now it is 3 to the 6. So 6. So you just add this voltage, you will get the total voltage is 6. So according to the substitution theorem, we can represent a particular branch according to substitution theorem for a linear time invariant system. A particular branch can be represented in different ways like voltage source, current source, or the combination of these two, or in series with resistance, or in series with a voltage source, or in parallel with a current source. So this is just about the substitution theorem. The only one question is asked from this substitution theorem that we will discuss. So what is that question? Let's have a question. Now अभी तक जो एक एग्जाम में एक ही क्वेश्चन देखा गया है, न्यूमेरिकल जो इससे आया हुआ है वो हम डिस्कस कर लेते हैं. क्या है देखते हैं. And this is your last theorem. Now, what is that question? Let's see. So, question number is 1. In the circuit shown in figure, voltage across 2 ohm resistor. 2 ohm resistor is 20 volt. Okay, is 20 volt. The 5 ohm resistor connected. The 5 ohm resistor connected between the 5 ohm resistor connected between terminals A and B can be replaced by an ideal. The first option is voltage source of 25 volt with plus terminal upward. And next option is the voltage source of 25 volt with plus terminal downward. And next option we have current source of 2 ampere upward. And the last option is current source of 2 ampere downward. Now what is the figure? Let's see. So figure है आपके क्वेश्चन का ये E वोल्ट प्लस माइनस R1, then we have R2, then we have 2 ohm, then we have parallel branches, and what are their values? 1 ohm and 3 ohm. Then we have 5 ohm. Then we will also have 5 ohm. And here we are marking the terminal as AB. So this is your question. Now see what is your question. पहले तो पढ़ लेते हैं क्वेश्चन को. In the circuit shown in figure, the voltage across 2 ohm is 20 volt. Okay. The 5 ohm resistor connected between the terminal AB can be represented by an ideal. Now ideal में जो है वोल्टेज सोर्स भी हो सकता है और करंट सोर्स भी हो सकता है. तो देखते हैं क्या होता है इसका आंसर. ना so according to the substitution theorem, a particular branch can be replaced into different ways. Okay. So first हम क्या करते हैं, हमें जो क्लू दे रखा है वो दे रखा है ये. So voltage across the 22 ohm resistance is 20 volt. Now it is 20 volt. अगर आप क्वेश्चन को दोबारा ड्रॉ करेंगे तो ज्यादा अच्छा रहेगा. सो करंट कितनी हो जाएगी यहाँ से, अगर मैं यहाँ देखूं I is V by R. So I equals to B by R से देखा जाए 20 divided by 2, that is 10 ampere. So 10 ampere current is in. If 10 ampere current is into the circuit, then 10 ampere will be out. So according to the Kirchhoff law, जितनी करंट इन हो रही है किसी पर्टिकुलर सर्किट में उतनी ही क्या होगी, आउट होगी. अदरवाइज आप एक काम और कर सकते हैं, ये इन दोनों में करंट डिवाइडर लगाइए और आंसर आ जाएगा ना. अगली बात क्या है, अगर यहां देखें ये जो दो रेजिस्टेंस पैरेलल में लगे हुए हैं, इनके इनपुट पर कितनी करंट है, 10 एम्पियर. और अगर हमें पता हो दो इक्वल वैल्यू के रेजिस्टेंस पैरेलल में लगे होंगे तब जो करंट है वो हाफ हाफ डिवाइड होगी. अगर नहीं पता है तो फिर से समझ लीजिए. अकॉर्डिंग टू दिस आई ए बी करंट डिवाइडर लगा रहा हूं मैं, 10 मल्टीप्लाइड बाई 5 डिवाइड बाई 5 प्लस 5. ओके, सो इट इज 10 that is 5 ampere. So the current in the AB branch is 5 ampere. Okay, so 5 ampere, and this is if you have 5 ampere current, and in the passive element, according to the passive convention, the current will flow from higher potential to lower potential for the passive element. So it is 25 volt. Now I can represent the first way to represent this branch, particular branch AB. This is your A and this is your B. How much is the resistance? 5 ohm. Now this is a branch that we have to substitute by a particular value. So it is 25 volt, and how much is the current? The current is what? 5 ampere. So I can represent, because we have only two options, either the current source or voltage source. So the first way to represent this is, what is that? I can represent this as 25 volt, where A is positive and B is negative, with a current of how much? 5 ampere. And the next way is what? I can represent with the current source of 5 ampere down, with A positive and B negative. So I can represent this particular branch into two ways. 25 voltage source with A positive, B negative, a current source of 5 ampere with A positive and B negative. Let's see the option now. First option, a voltage source of 25 volt with a plus terminal upward. Yes, correct, ये बात ठीक है. With a voltage source 25 volt with plus terminal downward, ये ऑप्शन गलत है, क्योंकि हमारा जो डाउनवर्ड वर्ड तो है, डाउन जो टर्मिनल है वो तो माइनस है और ये कैसा है, प्लस. तो ये ऑप्शन तो गलत हो गया. करंट सोर्स के बारे में देख लेते हैं. एक करंट सोर्स ऑफ 2 एम्पियर, गलत, करंट सोर्स ऑफ 2 एम्पियर, तो ये दोनों जो ऑप्शन है वो गलत हो गए हैं। किस वजह से गलत हो गए? क्योंकि हमें करंट कितने की चाहिए? 5 एम्पियर। सो योर ऑप्शन ए इज 101% करेक्ट। सो सब्स्टिट्यूशन थ्योरम को अगर मैं समराइज करूं तो क्या है? According to this theorem, for a linear time invariant circuit, a particular branch can be represented by in different ways, like ideal voltage source, ideal current source, in parallel with a current source and resistance, in series with a voltage source, or maybe different ways हो सकते हैं। So this is about the substitution theorem। अब हमारा जो डीसी पार्ट है ऑलमोस्ट खत्म हो गया है। एक मैं लेक्चर और अभी लेता हूं इसी पे कि जस्ट आई विल कंपेयर ऑल द थ्योरम्स, किरचॉफ लॉ, at which property they are working, application on the behalf of application, property, where it is applied, not applied, इन सभी बातों को लेके मैं किरचॉफ लॉ है या नोडल मैश है, इन सभी को मैं कंपेयर करूंगा। और हमारी जो डीसी सर्किट एनालिसिस है वो अब खत्म हो गई है। अब जो हमारा नेक्स्ट लेक्चर होगा उसमें हम लोग स्टार्ट करेंगे स्टेडी स्टेट सिंगल फेज एसी सर्किट, and that is most important from the competitive point of view। तो हम स्टार्ट करते हैं अपना कंपैरिजन ऑफ ऑल द थ्योरम्स, किरचॉफ लॉ, नोडल, मैश, एवरीथिंग स्टार्ट करते हैं अपना ये पार्ट।